no, that's not a function because there's a picture for me. But also, do you remember y squared is not a function? On this right here, would that pass the vertical line test? It would, guys. That's going to be a function for us. Number 7, would that pass the vertical line test? Yeah, that's just a plain parabola. That's a function. Would this pass the vertical line test?
No.
No. All right. So now that we've determined that, we're going to test for symmetry, and you're going to have to do it algebraically, and the work I show you is the best way to do it tomorrow to get your credit. All right, so I write too big. There's not enough room for me. So what I'm going to do is I'm going to recopy that and show you how to show your work. So the original problem, number 5, is x minus y squared equals 1. And you have 3 symmetry tests that you have to pass. You have to pass to see if it's symmetrical around the x-axis. And the way that you do that is you're going to plug in a negative y for the positive y. Then you're going to have to test if it's symmetrical around the y-axis. And if it's symmetrical around the y-axis, you know it will be because we're replacing x with negative x. Y'all, I'm just kind of recopying this stuff a little here so I don't have to scroll back and forth. Yes, ma'am?
After one test fails, do we automatically know it's not a function and we don't have to test
We'll summarize it. You'll figure it out. There's a pattern. For the origin, you've got a 1-2 punch. You got to replace your y and your x. It's the only way you're going to figure out if it's determined symmetrical about the origin. All right, so here we go. For the y-axis. Oh, you know what else is your best friend on this? Parentheses. Parentheses, guys. Use parentheses when you drop a negative in. That way you won't accidentally lose it. So, see this? I'm going to drop this in for that y right there. So, it is going to be x minus negative y squared equals 1. And guys, let me ask you a question. If this negative y, if it was a negative 3, what's negative 3 times negative 3? A positive. What if I input a positive 3? What's positive 3 times positive 3?
3.
Positive. So anytime you drop in a negative to an even exponent, it's going to be positive. So this, if I cover everything up, what's negative y times negative y? Y squared. Positive y squared. So this is going to simplify to x minus y squared equals 1.
So
Nothing changed. So tomorrow when you prove this, I just want to make sure Miss Harrington knows I know what I'm talking about. I'm going to write, yes, it is symmetrical. I'm even going to draw a bubble around that. She is not going to miss that. We plugged in a negative y. We ended up with the same thing. Yes, it is symmetrical about the origin, about the x-axis. All right, so now let's go ahead and take a look at the x-axis. So just because it's yes on here does not mean these are going to be no. Watch what happens. On this, we're going to use our friend Mr. Parentheses. We're going to drop negative x in for plain x. And we're going to recopy the rest of the problem. And guys, I did use those parentheses to show you that I put in the substitution. The parentheses don't really matter. It's going to be the same as this. Did I end up with what I started with? No. It is not symmetrical around the y-axis. So it's not symmetrical around the y-axis. Let's see if it's symmetrical about the origin. So remember, for the origin, it's a 1-2 punch. You have to drop in negative x, and you have to drop in negative y. So this is going to be negative x minus, remember that term's positive. Is that what we ended up with? Are those signs exactly the same? No. So it is not symmetrical about the origin. All right, so let's take a look at problem number 6. That's it. That's all I needed. That fulfilled the instructions. Prove and confirm your answer algebraically. We confirmed it was symmetrical about the x-axis. We confirmed that it was not symmetrical about the origin or the y-axis. All right, let's take a look at number 6. Number 6 is xy equals 4. And again, we're going to see what happens around the x-axis, the y-axis, that's an x, the y-axis, and of course the origin. For the x-axis, what do I change? Yeah, it's the other one. For the y-axis, what do I change? You better tell me. I need to hear you. And for the origin, what do I change? Both. You tell me now, I'm going to feel more confident. You're going to be ready to roll tomorrow when I can't help you. All right, so let's go ahead and drop these in. So x, and then it's not a positive y anymore, it's a negative y. Y'all, what's a positive times a negative? It's negative. This is a negative product right here. I'm just going to put this negative in front. Is that what we started out with? No. It is not symmetrical about the x-axis. What do you think is going to happen for the y-axis? Negative x times a positive y. Again, what's a negative times a positive? A negative product. So is this what the original equation looked like? No, it's not. So it is not symmetrical around the y-axis. Now let's try the origin. We're going to make them both negative. What's a negative times a negative?
Right.
Positive. So we have a negative x times a negative y. We are going to end up with the exact same thing that we started with. So number 6 is symmetric around the origin. Be careful. It's just analyzing positives and negatives. Use parentheses, guys. Parentheses. All right, let's take a look at number 7. So for number 7, we have a parabola. So y is going to equal negative x squared plus 6. All right, I need to hear you guys because you won't get a cheat sheet tomorrow. What do you change to see if it's symmetric around the x-axis? There you go. There we go. What do you change for the y-axis? Yes, indeed. And then the origin is a 1-2 punch because you change both of them. All right. So, again, look at where y is. Y is over here on the left side of the equal sign. So I'm going to write negative y equals negative x squared plus 6. Thank you. And they have to be identical. Ooh. Do these match? No.
Yes.
Those don't match. Those match and those match, but do these match? They do not. This is important. If you have a highlighter, find a highlighter. So when you drop in negative x, I really want to compare it to the original, but when you drop in a negative y, I want to compare it to the original, but the original is a positive y. This is an equation. what can I multiply this equation by to make that y positive? That's right. Let's multiply it by a negative 1. And what happens when you multiply by a negative 1? Just all the signs change, guys.
X squared minus 6.
Yes.
So it's still
It's going to be positive y equals positive x squared minus 6. These definitely do not match, so it is not symmetrical around the x-axis, guys. If you drop in a negative y, multiply by a negative 1. If you drop in a negative y, multiply by a negative 1. Just to see if they're the same. It's so much easier to see. Alright, let's see what's going on with the y-axis. So we're going to write y equals, and remember, we're going to drop in a negative x for the x squared plus 6. A negative x times a negative x is positive. Then you distribute the negative. So when you do your correct order of operations, it's going to look like this. Is it symmetrical about the y-axis? Is that the same exact thing as the original? Yes. So it is symmetrical around the y-axis. Alright, let's see what's going on with the origin. We're going to change everything. So negative y equals, drop your negative in those parentheses. And guys, remember over here, see this? See how this is the same exact operation? So remember, this right side over here, this right side is going to be this right side. So negative y equals, negative times a negative is positive, distribute your negative. However, these are not identical because remember we had to change the y also. What do you multiply when you change the y? Negative 1. And remember, when you multiply by negative 1, the shortcut, just change all the signs. Just change all the signs.
I have a question.
Yes.
What's the point of changing it if it's gonna end up changing all the sides? And
Just, you don't have to, as long, if you recognize that it's okay. I'm changing it because I want my y values to match. That's it. So y equals positive x squared minus 6. Do these match? Well, actually, I am going somewhere. Hang on. These do not match, so it is not symmetric to the origin. Let's back up for a moment. Problem 5. Here's the picture. Was that going to pass the vertical line test? Oh, it's off. That's not going to pass the vertical line test, right? Is that a function? Is this a function if it doesn't pass the vertical line test?
No.
All right. Where's another one that's not a function on here?
8.
8. Y'all, where's the center of that circle on problem 8? So, are all of these points equidistant from the origin?
Yeah.
Are all these points symmetrical to the x-axis? A circle? Are they all symmetrical to the y-axis? Yeah. We're going to prove it, though, algebraically. Why are we going to prove it algebraically? Oh, because I'm quizzing you on it tomorrow. All right, so let's go ahead and look at problem number 8. So problem 8's original equation was x squared plus y squared equals 25. All right, so x-axis, we are going to change the y value to the negative y value. Did you have a question, Yuri?
Oh, I was just saying value.
Oh yeah, when it's time, you can go. You're good, thank you. And then for your y-axis, remember you are changing the x value. And then of course your 1-2 punch, you're changing both of them. Okay. All right. X squared plus a negative y squared equals 25. Guys, when you do your math here, are you going to end up with the same thing?
Yes.
Yes, you are. Good job. You need to write yes right here. You better make sure I see that yes tomorrow. All right, let's do the y-axis. When I plug in a negative x squared, am I going to get the same exact thing? What's negative times a negative?
Oh, yeah.
Remember, a negative x times a negative x is the same thing as a positive x times a positive x. Negative 3 times negative 3 is the same thing as positive 3 times positive 3. So these, ooh, we're going to write a yes on here also. What do you think is going to happen when I plug in both negatives?
Yes.
Yeah. They're all symmetrical.
They are all symmetrical,
Like you said at the beginning.
like we discovered at the beginning. That is correct.
Just those ones.
Now look at your work and look at the x-axis. Look at your work and look at the x-axis. Which graphs were symmetrical about the x-axis? What problems?
X-axis.
One.
Yep.
Yes.
This,
No.
5 and 8. Is 5 a function? No. Is 8 a function? No. So listen. Every time you figure out algebraically that an equation is symmetric about the x-axis, it's not a function. So number 5, we got yes right here, not a function.
It's based on.
If it's symmetrical, if you get a yes on the x, yes on the x, not a function. So same with problem 8. We got yes on the x, not a function.
What about the Y?
It's a function too.
So
Oh.
where we got no's on the x, it is a function. Number 6 is a function. Number 7, was number 7 a function?
It's no in the.
Is number 7 a function?
Yes.
Yes.
So yes.
Remember, yes on the x means no on a function.